Let's continue evaluating functions using function notation. Now you'll notice the first sentence there says the most commonly used symbols to name functions are f, g, and h. It's just alphabetical order. It's nothing different than that. Notice that that's kind of nice because we can be talking about more than one equation and refer to them by the name of the function. For example, in example 2 here, it says for f of x equals 2x squared minus 3x. And so that is, I can refer to that equation as simply f of x. The next equation I could refer to as g of x. And finally, the third, h of x. So that also helps me to distinguish which equation I'm talking about without having to repeat the whole equation. We're ready to tackle the problems in example 2. The instructions say find the following. And part 1 has f of negative 2. So we need to understand what the meaning of f of negative 2 is. Well, the original equation from above is this, 2x squared minus 3x. So the meaning of negative 2 is when x is equal to negative 2, find the y value. Because as you'll recall, we used to write functions in y equals form. And so really f of x is just finding y. So we substitute, everywhere we see x, we substitute this negative 2 in this equation. So the meaning of f of negative 2 means x equals negative 2, substitute it in everywhere you see an x, and solve, or find the answer. So we'll do that. So f of negative 2 equals, order of operations, say you'd square first. Negative 2 squared would be 4, so that would be 2 times 4. A negative 3 times a negative 2 is a positive 6. So then you would have 8 plus 6. And 8 plus 6 is 14. So f of negative 2 is equal to 14. Again, the meaning of that is that when x is equal to negative 2, y equals 14. Part 2, we're finding g of 3. And again, g of 3 means find the value of y when x equals 3. So we will substitute this 3 everywhere we see x in the equation. So therefore, g of 3 equals 4 times x, but we will substitute the 3 in. Minus 2 remains the same. Over 5 times x, substitute the 3 in. Minus 1. So that would be our substitution. So g of 3 equals 12 minus 2, which is 10, over 15. 5 times 3 is 15, minus 1 is 14. Now we would want to reduce the fraction. When we reduce it, we would divide top and bottom by 2, so we would get 5/7. Again, it's important that you understand what that means. That means when x was 3, y, or g of x, is 5/7. Part 3 is asking us to find h of a, and this is no different, even though it seems a little confusing. We are simply substituting the a in for the x, so x equals a. So you can see up above that h of x equals 3x minus 5. So instead of 3x, I will substitute a in for x, which will make 3a minus 5. Turns out that's all you can do. That's simplified, and that's the answer. So h of a is equal to 3a minus 5. Number 4. For similar, however, it's h of a minus 2. So once again, everywhere we see x in the equation above, we will put or substitute a minus 2 in. So instead of 3x, it will be 3. Because I have two terms, a minus 2, I'm going to put it in parentheses. And then I still have to include the minus 5 in the 3x minus 5. Now, we want to simplify, and so we can use the distributive property. The distributive property simply means that because I have 3 times parentheses, I have to multiply the 3 times both the a and the negative 2. So 3 times a is 3a. 3 times negative 2 would be negative 6. I can do one more step. I can simplify by combining the negative 5 and the negative 6. So h sub a minus 2, the final answer, will be 3a minus 11. And that just comes from combining the negative 6 and negative 5. Choose which video you would like to review, either the function notation or one of the examples from the section.